Carco math. All right, ladies and gentlemen, here we are with our last lesson for our topic 8. We're on 8.5, I believe. We are trying to identify if something is linear, exponential, or quadratic. Okay, so first we have to remind ourselves, what's a linear, quadratic, or exponential? Like, what do they look like? What are these functions, right? We have to go back. We've been currently working on quadratics, right? Quadratics have a degree of 2, and they form a parabola for a graph. Okay, before quadratics, we were working with exponential functions. We had this nice little curve to it. If you remember down here, we get really, really close to 0, but never exactly on or over 0. And then it exponentially or very quickly goes up. And that's problems that have exponents, not a variable and an exponent, but an exponent with a number here. And then you have linear graphs. Okay, linear graphs are just straight lines. Those are the ones that we worked on before, and then you also worked on probably in the Math 7, 8 in previous years. You've looked at linear equations. Okay, so we're going to start with identifying what are the rules to identify which function type represents a set of data. So if you are given this table right here, just this table, the x's and y's, in order to identify what type of function it is, you're going to start looking at its differences. Okay, so let me show you. A linear function is going to have the differences, first differences constant. So what that means is, okay, when I look at a set of data, I first need to confirm that the differences in x's are constant. So you need to make sure that your x values are a constant change. If they're not a constant change, then it's not going to be one of these 3 functions. Okay. Also, if we know that if we have the same or 2 different outputs for one input, it's not a function. Okay. So then after we've confirmed our x values are the same, we're going to start looking at the differences. The differences are, when we talk about differences, that's between consecutive y values, and those are called our first differences. So when I subtract the consecutive values of y, right, the ones that are right next to each other in order, when I subtract these from each other, I should get a constant answer. That means I should get the exact same answer every time. If that happens, it is a linear function. Okay, so this one right here, this example is an example, whoopsie, of a linear function. Okay. Next, we have quadratic functions. Okay, again, you're going to look at those x values, make sure that those are consistent as well. But if your first differences don't work out, if your first differences are not constant, check the second differences. And second differences is when you take this difference, the one that you already subtracted, your first differences, and the next first difference, and you subtract them there. So when I take this, right, the 6 came from here, and the 10 came from here. When I subtract those numbers, I should get a consistent, constant answer, okay? When I then do 10, 14 take away 10, I get a constant answer. When I do 18 take away 14, I get a constant answer, okay? So when the second differences are constant, that means that we have a quadratic function, which are the ones we're talking about right now. And if you haven't been doing so, you should be writing these things down. You can go back and pause the video and write down these notes. All right, the last type of function we're going to look at, let's pick a nice pretty color, are exponential functions. Exponential functions, again, make sure your x's are consistent, but exponential functions, when first and second differences are not constant, you're then going to look at the ratios of the consecutive y values. So remember, you have to go in order, because if I just start looking at ratios, the ratios in a linear equation are going to be the same if it is proportional. So that's going to throw you off, and you're going to think that it's exponential when really it's linear. So in order for it to be exponential, you first have to check the first differences. Those are not constant. Then you have to check the second differences. Those are not constant. Then check your ratios of the y values. And if those are constants, the ratios of the consecutive y values are the same, then it is an exponential function. Okay, so we're looking at first differences, second differences, ratios of y. That's what we're going to look at. And that's the whole topic here, guys. We just need to be able to identify which one's which. I need to be able to identify from a table of values which of these three functions am I looking at. Okay, so we're going to do one together. You're going to do one on your own. And then I have a couple that we're going to do together. And then I have another one we'll do together, and you'll do another one on your own. So here is my table I'm working with. So remember, I need to start looking at differences. Okay, so I'm going to first check my y's. Are my y's consistent? Okay, yes. Or sorry, my x's. My x's are changing by 1. Those are consistent. So now I'm going to start looking at differences. Okay, -5 take away 2 is -7. Oh no, sorry. Take away -2. Sorry. Oop, try that again. -5 take away -2 is equal to -3. Okay, -14 take away -5 is equal to -9. Uh-oh, I'm not getting constants. I'm not getting consistent, so I don't think it's linear. All right, so if I look at my list here, so far, I do not think that this is linear, okay, because I'm not getting a constant change. All right, I'm going to keep going just to make sure. Let's just make sure here. So like -29 minus -14 is equal to, let's see, 29 take away 14 is -15. Yeah, this is not constant, so it's not linear. Now I'm going to start, well, I have to continue because I need the second differences. So let me do the last one here. And in order to do second differences, I need at least 4 numbers. Take away -29, and that's going to get me why can't I? 21. Okay, so these are my first differences. First difference. Okay, they're not constant. All right, so I'm going to switch colors and I'm going to do the second differences. So now for my second differences, I'm taking these numbers, I'm subtracting them from here. So -9 minus -3 is -6. Okay, now I'm going to take these two numbers. -15 take away -9 is -6. Oh, I'm starting to get consistent. -21 take away -15 equals -6. These are my second differences, and because these are consistent, I can say that this is quadratic. Okay, so go ahead and try the same thing with B. Start subtracting your differences. Check your x values, make sure they're consistent. Then start subtracting your differences, and if both sets of differences are not constant, then look at your y value ratios. All right, we're going to do one more together so that we can practice one more time. This is from the Do You Know How section. It is in the later half of your student companion of this lesson. So find number 4, and it'll have these values, 0, 1, 2, 3, 4, and the y values are -2, 1, 10, 25, and 46. I believe this is on page 188 of your student companion. And we're going to do this one as well. We're going to start subtracting. Okay, so again, here we're going to have, I'll go back to my green. These are going to be my first differences. And then down here, I'll do my second differences. Okay, so first I checked my x's, they are constant. So I'm going to start subtracting. Okay, so the difference between -2 or 1 take away -2 is 3. The difference between 10 take away 1 is 9. Okay, they're not consistent. 25 take away 10 is 15. Okay, 21 take away 15, and that's 6. So these are consistent, and ironically, they're actually the same as the previous one. The differences are the same, but the numbers are different. But that means that it is quadratic. It's the last one we did together. So this is quadratic. So then what I want you to do is just go to number 5, do this problem, and then we'll go over in class and we'll see how you do. All right? No, wait, never mind. I forgot. We're going to go back and review the concept summary here. So I kind of wanted to show you this because it shows you what these linear equations are. So linear equations, the first difference is constant. And you can start to see this because here in this graph, it has the differences, the first differences, and you can see this line is a 2. But if I start changing m, you might notice that all of my first differences are still the same. If I start changing b, same thing. My graph is kind of moving around. And we'll pause this one so you can see the changes here. But my differences are still the same. So those are linear equations. This next one is looking at quadratic equations. So you can only see half the parabola here, but you'll get the idea. Okay, so I'm going to do the same thing down here. It shows these differences, the first differences and then the second. First ones are not constant, the second ones are. As I change A, my second differences are consistent no matter what A is. Okay, let's bring it back up so we can see it. As I change B, those second differences are constant. Okay, doesn't matter what B is. As I change C, same thing. So just kind of proving the point of that this is always true. Okay, second differences are constant. And then the last one we're going to look at are exponential. So we're going to do the same thing here. You can see here this is R for ratio. Okay, these are my differences. Those are not constant, but my ratios are constant. So if I change B, still get the same ratio. It's kind of hard to see, it's going so fast. But you can see they're the same. And if I change C, they're staying the same as well. Now we're done. Hopefully that just gives you a visual and it gives you a reminder here that exponential has constant consecutive ratios of y. Linear was first difference and quadratic is second difference.